of results which will be kind of handy. This is a basic sheet on determinants, but there are two results. No. Okay, it's a sheet on determinants. All right. Sorry for using unworthy adjectives. So, three results which we use often. We use very often in determinants, and as ready reckoners, don't use them in school unnecessarily. But one determinant, you know, this one see, in this, if you plug in A equal to B, then first two columns will become identical, right? If you plug in A equal to B, then column 1 will become identical to column 2. That means the value of the determinant will become 0. That means on plugging A equal to B, delta becomes 0. Delta becomes 0. That means A minus B must be a factor of this. That means A minus B must be a factor of delta. Yes or no? That means delta must be some A minus B into something. Similarly, if you plug in B equal to C, then the second and the third columns will become identical. Delta will then be 0. That means delta becomes 0 when you plug in B equal to C. That means B minus C must be a factor of delta. Similarly, plug in C equal to A. First and the third columns will become identical. Delta will be 0. That means delta is 0 when C is A. That means C minus A must also be a factor of delta. Yes or no? That means A minus B, B minus C, C minus A. If you end up simplifying this determinant, then A minus B, B minus C, C minus A are all factors of delta, are all factors of delta, right? So for sure, of the very many things, A minus B, B minus C, C minus A are factors. Now, let me look at the degree of the terms here. When you expand this indiscriminately, what kind of terms do you get? Like a BC square minus B square C into 1 kind of a thing, which is of degree 3. Do you see that? 1 plus 2, 3, 2 plus 1, 3. Isn't it? All terms are of degree 3. That means this determinant must be of degree 3. In any term, if you add the powers of A, B and C, it will add up to 3. Yes or no? Now, this is already a degree 3 expression. Say A, B, C is degree 3. A minus C is degree 3. All terms here are degree 3. That means there will be no other terms in terms of A, B and C in this product. That means this would be at best lambda into this, where lambda is independent of ABC, where lambda is a scalar independent of ABC. Yes or no? Now, so this will be identically equal to this. So question then is, what's the value of lambda? The question is, what's the value of lambda? Now, one of the terms in the determinant is 1bc square, right? That's a leading term of the determinant, right? 1 into b into c square. Of the very many terms, this will certainly be a term in the determinant, right? So I can, in 1bc square here will be equated to the 1bc square kind of a term there, because they are, this is an identity, this is an identity, right? So now how do you obtain 1bc squared? Minus b into minus c into minus c into lambda. That's a term containing bc squared, yes or no? See, how do you obtain a bc square in this product? Minus b into minus c into minus c is a bc square, yes or no? So lambda into minus b into minus c into c will be the bc square kind of term. and they must be equal. It's an identity. That will give me lambda equal to 1. Do you realize that? The 1 BC square there should have the same coefficient of 1 BC square on the right hand side. 1 BC square on the right hand side has coefficient lambda, which must be equal to 1 there. Yes or no? So equating coefficients of similar looking terms in an identity. You can do that, right? In an identity you can equate coefficients of terms that look the same. Right? So that gives me lambda equal to 1. Good for us. Plug in lambda equal to 1. That means this determinant is equal to A minus B into B minus C into C minus A. You know what I'm saying? So remember this as a regular result. Remember this as a regular result. If you finish copying, let me give you another common result. Can I wipe this off? Okay. Say this was A cubed, B cubed, C cubed. Again, if you plug in A equal to B, first two rows will become identical. First two columns will become identical. So A minus B must be a factor. If you plug in B equal to C, this column will become identical to this column. That means B minus C must be a factor. If you plug in C equal to A, then this column will become equal to this column. Determinant will become 0. That means C minus A must also be a factor of this. So one thing for sure, exactly the way I discussed the previous determinant, A minus B must be a factor of this, B minus C must be a factor of this, C minus A must be a factor of this. That's certain. Now, what's the degree of this determinant? That means when 4, right? See, the kind of terms are 1b c cubed. Add the powers of b and c. A, b and c, 4. Right? Degree 4. This product is like degree 3. So I need to build in another degree in it. Right? I need to build in another degree in it. What I do is, if I multiply it with A plus B plus C, and you know, I will have to be impartial towards A, B and C in this expression. So I'm not saying, I could have said 2A plus 3B plus 5C also. That would have also made it degree 4. See, this is degree 3 and I want to make the right hand side degree 4. So there are so many ways I could have done it. I could have said this into A cubed would have also, or this into A would have also made it degree 4. This into B would have also made it degree 4. This into C would have also made it degree 4. Right? But because of symmetry considerations, I show no partiality towards A, B and C for the sake of the looks of this expression. So it's like A plus B plus C. That's degree 4. Now, again I need a lambda so that I can generalize the right hand side to cause this to become an identity. What's the coefficient of the leading term here? Coefficient of the leading term is 1 BC cubed. Lambda again will equate the coefficient of the leading term on the right hand side. That will cause, right? Do you realize? BC cubed would cause lambda to become 1 once again. How do you obtain BC cubed? How do you? Minus B into C minus C into C into C. Right? Minus B into minus C into C into C. That's BC cubed. Equating coefficients of BC cubed on both sides, I again get lambda equal to 1. So this again is a commonly used result. Use this as a ready reckoner in my class, not in school. Right? Another determinant worth a mention Can I wipe this off? Hmm? This determinant, it's a cyclic determinant, ABC, BCA, CAB. This is a cyclic determinant, right? Now the operation that you can perform on this is this is row 1, this is row 2, this is row 3, right? Remember I told you an operation that you can perform on rows and column, right? So what I do is row 1 to be replaced by row 1 plus row 2 plus row 3. Row 1 to be replaced by row 1 plus row 2 plus row 3. So when I do that, row 1 to be replaced by row 2 plus row 3. So this will become A plus B plus C. This will become B plus C plus A. This will become C plus A plus B. So which is like A plus B, the first row. This determinant, and I can take A plus B plus C common from the first row. First row, so I get 1 1 1 BCA CAB, right? This is what I get. I took A plus B plus C common from the first row. Then what I do is, this is my column 2. On column 2 I do a C2 minus C1, C2 minus C1. This is my column 3. On column 3 I do a C3 minus C1 to cause these two become 0. Yeah, I'll repeat. I'm saying on column 2 I'll perform our operation column 2 minus column 1, so that this becomes 0. This will become C minus B. This will become A minus C. On column 3, I do a column 3 minus column 1. So 1 minus 1, 0. A minus B, B minus C. Right? This is the operation I perform. So this determinant will become A plus B plus C. Determinant 1, B, C. 0, C minus B, A minus C. 0, A minus B, B minus C, right? You realize what I did here? Now now expand it. All right. So it's easy to expand this because A plus B plus C, and then into 1 into this minus this into this. The other two will be 0 when I expand about the first row. So I'll simply have C minus B. Have I made a mistake? C minus B, B minus C. It's okay. No. B minus C minus A minus B, A minus C. Hey. Right? Now when you simplify this is what you will get. A plus B plus C minus CA. This is what you will get, which would then be minus of A cube plus B cube plus C cube minus 3ABC. Is again a regulation result. Sorry, so sorry. किसका कट जाएगा? So sorry. Right. Thank you. Got it? So this again is a very commonly used result. Remember this again. Word of caution is for my class, use this as a regulation result, but for school, no result is regulation result. Okay? Do it the way your reverend teacher in school has asked you to do it. Okay?